Good afternoon, students. This is the check. Can you hear me? Can you see the screen?
Yes, sir.
Yes. Yes,
All
sir.
right. All right. Today's supposed to be a short session. I'm just gonna finish up a few questions that we have left on this paper that we're doing. This June 2022 paper. We have done number 1 to number 6 yesterday. And so I'm just gonna finish up number 7, 8, 9, and 10 today. And then I'll take any question from the multiple choice paper that I sent that anybody want me to maybe explain. I know I've not yet sent the solutions or the answers. I'll send it later. But still, if there are any questions anybody want me to just say something about on that multiple choice paper, then I'll do it. All right, so let's continue with this paper. Don't need the calculator here. All right, so we have gotten to this question, number 7. Question we have done before, but I always say no problem. More maths equals better. And just as you see me repeating, doing the question multiple times, that's how you have to approach this thing. You see a question that you have done before, no problem, you do it again. Once you come across it, you do it again. It's a part of the revision process. All right, especially if you don't master the thing as yet. Right, you keep practicing, you stay sharp. And it's very important, very, very important. All right, so let us look at this question, the pattern question, number 7. It says, at an entertainment hall, tables and chairs can be arranged in 2 different ways, as shown in the diagram. Arrangement L is this way, is that the tables are placed side by side on the long side, and arrangement M here, tables are placed side by side on the short side. So just logical reasoning tell us that this arrangement will allow you to seat more persons because you're only cutting off the short side. All right, in that shape. In this shape, you're cutting off the long side, then you're seating less persons. So that's sort of that just kind of makes sense to get go on the get-go. Question says we are to draw the 4-table design. Draw the design for 4 tables on arrangement L. Arrangement L is the top one. So we see that what is happening is that they keep adding a table. All right, so to get the next one, we add a table to design 3. And we're going to move these chairs and put another table here. And then put chairs around it. All right, so if I were to draw, just trace over this one because I have the device, I can trace over it. Copy it down because I draw shape 4. We normally copy shape 3 and add to it to get shape 4. That's how these questions are done generally. All right, so instead of these rectangles, I'm just going to put some little dots for the chairs. All right, I'm not going to put these yet because I know that those are going to be moved. I'm going to form the next shape, but all these chairs are going to remain. All right, so I'm going to start with this, and then I'm going to move it down here where I'm going to draw shape 4. You have to draw it from scratch. All right, so that's my shape. I'm going to add one more table to this now. So table I'm adding to this now is another rectangular table here. I'm adding to this one, same size table. But I'm adding, maybe I should use a different color to show what is add on the additional piece in purple. So I'm adding this additional table. And I'm putting 2 chairs on the short side of here. I'm putting 3 chairs on the long side down here. And I'm putting 2 chairs on the short side. And that is my shape or the diagram for 4 tables. Everybody good with that? Everybody can appreciate that?
Yes, sir.
Beautiful. Then we come to the table. There's always a table with these questions. It says the number of chairs C that can be placed around a given number of tables T for each arrangement L or M forms a pattern. So the values of C for the first three diagrams for both arrangements are shown in the table below. Study the pattern of numbers in each row of table, and then we have to complete the rows marked 1, 2, and 3. So this is now for arrangement L. This is for arrangement M. So let's look back which one was what again. So arrangement L is a long one. We're going to put them side by side like this. And arrangement M is when they put them a long way like that. All right, turn them on the short side. Let's confirm that. Arrangement L is the joint alongside. All right. All right, so what we want to do now is look at these numbers and see if we can get a formula. As the method I like to use, I like to teach to use, is one where you get a formula in terms of the number of tables or the figure number. And then we can use that formula to populate these missing values. All right. So you want to establish a formula. And a lot of most of the questions in this topic are such that it is easy for you to get a formula. Because what does that mean is that they'll be increasing by the same amount as you go from row to row in the table. So in this one, for example, this is an increase of 4. And this also is an increase of 4. So it means that this row, this column, sorry, formula starts with 4 times n. Once it increases by 4 consistently, then the formula starts with 4n. 4n is a part of the formula. But it's always 4n plus some value or minus some value, and that value also can be 0. So what you need to do to decide what you're adding or subtracting is to look at the first shape, at the first figure there. But that figure up there is 10. And in that figure, the n is equal to 1. So if you put this formula on that figure up here, where the n is equal to 1, you have 4 already, but the total is actually 10. 4 times 1 is 4. You have to add 6 to make it 10. And so this formula, we need to add 6 to it. And basically, that's the formula. And you can test it on the second one if you like. So you take the 2, for example, drop it on the formula down here. You get 4 times 2 is 8. And then 8 times 6 is 14. So you can accept that formula. And if you want, you can test on the third one as well. 3. Drop the 3 on the formula. You get 4 times 3 is 12. 12 plus 6 is this 18. So based on that, we know that the formula is correct. All right? Formula is correct. Let's look at if this one increasing by a standard amount each time as well. So from 10 to 16 is an increase of 6. That's a plus 6. Then from 16 to 22, that's another plus 6. So good. Each row, we're increasing by 6. So since we're increasing by 6, 6 times this n is a part of the formula. 6n is a part of the formula. But we look at the first one. The first one again is 10. And this is what we have is 6n. Now in the first one up here, the n is equal to 1. So it's like we have 6 already. 6 times 1 already. To get it to be equal to 10, we have to add a 4. So it means that the formula becomes 6n plus 4, as simple as that. And then again, we can test to see if we can get this value when the n equals 2. So we take the 2, drop it on the formula. We get 6 2 is 12. 12 plus 4 is this 16. So the formula good for that. And we can test it on the third one as well. It's okay. When the n equals 3, take the 3, drop it on the formula. And we get 6 3 is 18. 18 and 4 is 22. So good, formula works. So know that this is the formula that we can use to populate these values. All right, let's go now. Sorry about that. So right here, the n is equal to 4, and we have the value for 3. So in this row, we can actually just continue the pattern. We can continue the pattern for this row because this is the next shape. 4 is the next shape. All right. So we can just add 4 to this and get 22. And here we can just add 6. Because remember, this one is increasing by 6. We can add 6 to this and get 28 by just doing that. Or you could have taken the 4, put it on the formula, and get 4 times 4 plus 6. 4 times 4 is 16 plus 6 is 22. 22. So we could have also used a formula. Again, for this one, we could also use the formula. Could take the 4, drop the 4 on this, and get 6 times 4 plus 4. 6 times 4 is 24, plus 4 is 28. So you can get that one using the formula or just recognizing that it's the next shape. Then now for this row, what it is that we know this value. And we really would like to find the value of n over here. So we know that in this row, the n can be found by equating this formula to 130 to find out what the n is over here. All right, so let's work it out times 6. So we're gonna put 6n plus 4 equals 130. All right, that's for right here. And we're solving for the n. So first we're gonna subtract that 4. And we're gonna get 6n equals 126. So we're gonna divide by 6. When we divide by 6, we're gonna get n equals 21. So it means that n is equal to 21 in this row over here. And so we can put the 21 here. And then to get this value now, we'll just take this 21 and drop it on that formula. So what we're gonna get here then in this row and in that cell is 4 times the 21 plus 6. Now 4 times 21 is 84 plus 6, and that becomes 90. All right, that becomes 90. So this one is 90. But go to that. But okay?
Yes, sir.
All right. Next part says, so I've completed the table. Next part says, layer needs to arrange tables to seat 70 persons. So it means that they want the number of chairs to be 70. For a birthday party, it says, which arrangement, L or M, will allow him to rent the least number of tables? Now, remember, we said it has to be the one we're using more chairs. Must be this one. And we can actually see it over here that the number is getting more. So when it's 2 tables, this has more. M has more. You can see it here. So when it's 3 tables, M has more chairs. Right? So M consistently has more chairs. But they want to justify your answer. You cannot just say it. So how you justify your answer is to calculate the number of tables you need for pattern L or for pattern M and show that the M one is more. You cannot just say it is M. But I said justify your answer. Use calculations. So we're gonna do, we're gonna say, okay, what the number of chairs to be 70? We're looking for pattern L, arrangement L or arrangement M. Let's do them separately. All right. So we want 70. So the number of chairs must be 70. C must be 70. So for pattern L, we're gonna put this equals 70 and solve it for N. So we're gonna get 4N plus 6 equals 70. Subtract the 6. We're gonna get 4N equals 64. Sorry, and then divide by the 4. Correct this. Divide by the 4, we're gonna get 16. N equals 16. All right, so if it's L we're using 16 tables. Then over here, we're gonna put this formula equals to 70. So you're gonna use 6N plus 4 equals 70. Subtract the 4, we're going to get 6n equals, what is it now, 66. Then divide by the 6, we're going to get n equals 11. So you see that this clearly will use less chairs. So this is the answer. So that's, which arrangement? Arrangement M. We need arrangement M. M is the answer. M, we need arrangement N because it uses less tables to seat the same number of chairs. So M is the answer right here. Very good at that. This is less tables. It uses less tables to see the same number of persons. You see, you need 16 tables in arrangement L to seat 70 persons. You only need 11 tables in arrangement M to seat same 70 persons. So they ask for what arrangement will seat the least will use the least number of tables. It is arrangement M, using only 11 tables to seat same 70 persons. But good at that? Question done.
Yes, sir.
You can go over the part where you found number 21, please.
21. 21 up here. All right. So remember, all right. So what happens over here is that we wanted to fill out this line. Let me erase these. All right. Let me erase these and do. So we did this line first, right? Which was also the next shape, but now I want to fill out this line. So in this line, the only information we know is that that is 130. And you want to find the n in this line. If you find the n in this line, they can use that same value n on this formula to find this figure. So I want to find what is the n first. Remember that in this column, all the values up here are obtained using this formula, where the n comes from over here. So what we're going to do to find the n on this line is to equate this and this, put them equal to each other and solve for the n. In other words, we want to know when this is equal to 130, what is the value of n? When you find that value of n, that is the value of n you have to put here. All right, so I'm going to equate them right here. I'm going to put the formula, this 6n plus 4, put it equal to the 130. I want to know what value of n is going to make it equal to 130. As I was solving for this n. First, we're going to subtract the 4 from 130. We're going to get 6n equals 130 minus 4 is 126. And to get the n, you have to divide by 6, like you divide both sides by 6 to get the n. When you divide 126 by 6, you're going to get 21, as 6 into this goes 1 time, and 6 into this goes 2 times. 6 and 12 is 2 times. So you're getting 21. Right? So the n is equal to 21 in this row. When n is equal to 21, that's when this formula comes 130. So that the 21 is a figure number over here. 21. Understand that so far?
Yes, sir.
Good. Now that we know that that is 21, we want to find the figure for here. So all we have to do to find the figure for here is take this 21 and put it in the formula for this column, and to work out the value for right here that we want. That is what I'm going to now do over here. Let me show it in red. So over here now, I'm going to put the 21 in this formula. That's going to be 4 times 21 plus 6 inside that cell, that value. Now the 4 times 21 is 84 plus 6. 84 plus 6 is 90. And so the value for here is 90. 90. All right, to that? What you gonna do for me now? What you gonna do for me now? Yes, you understand?
Yes, sir.
All right, so what you gonna do for me now, you see? You're gonna go and do the question over by yourself. And go back through the same process that I just explained. Do it over by yourself. And the video is gonna be there to help you if you need. Because these are all questions this topic have something like this that you have to do. We have to use a formula down here. Work out a value. A lot of them, 99% of them can be done that way. So I want you to do it over by yourself from scratch. All right? Make sure you solidify the understanding that you know how. All right. That finishes this question, guys. So let's move now to number 8. We have not done this topic in a while. That's why we have to revise. All right. This is a linear programming question. I'm not done. In fact, I think we have done this particular question before, but I bet a lot of persons don't remember. And that's why we have to revise. Right? It says a rental company has X cars and Y minivans. So X is the number of cars, Y is the number of minivans. You don't know X and you don't know Y. You don't know those values. I'm going to give you some limitations and constraints now about how the number of cars and vans can be used, all right? Or how the company can have those number of cars and vans. It says the company has at least 18 vehicles altogether. So 18 vehicles altogether means the sum of the vans and the cars and the vans. And it must be at least 80, at least 8, sorry, at least 8. No, at least 8 means 8 or more. Don't let the word least cause it to just write the less than sign. Put the English meaning to it. If you must have at least 8 something, it means that you must have 8 or more. If you're going to buy something and you don't know the cost for it, and you ask somebody how much for it, and then somebody said to you, it's at least $8 for it. It means that you need $8 or more. So we need to just appreciate that that's what the term means. At least 8 means 8 or 8 is the least. So you need 8 or more. And altogether means the sum of the vehicles. All right. So the inequality for this, they're going to ask you to write inequalities. The inequality for this information has to be that the X plus Y is greater than or equal to 8. So the total number of vehicles X plus Y must be greater than or equal to 8. All right. As a first inequality from this statement. Excuse me, guys. I keep telling you, I'm still battling a code. All right. It says the number of minivans. Remember, the number of minivans is Y, you know, guys. The number of minivans must be less than or equal to the number of cars. Remember, the number of minivans, which is Y, must be less than or equal to, they're giving you this one straight, less than or equal to the number of cars. The number of cars is X, and there are X cars. As a second inequality from this statement. And then now, the third thing they said is that the number of cars, which is X, must be no more than 9. No more than 9 means it can be 9 or less. It can't be 10, it can't be 11. So the number of cars, which is X, has to be less than or equal to 9. No more than 9. So these are the 3 inequalities that they're asking us to write here. See, write 3 inequalities in terms of X and Y other than these, but these are understood to represent this information. So these are the 3 inequalities, guys, that they just told us about. Everybody good at that? Everybody okay with that?
Sir.
Sir.
Yes, sir.
All right, so X plus Y must be more than equal to 8, greater than equal to 8, at least 8. 8 or more. The Y, put it down here, put some space between them. The Y has to be less than or equal to X. And then the X has to be less than or equal to 9. So those are 3 inequalities so far. We're going to have to rewrite these on a graph. So I'm spacing them out to write how you represent them on a graph. All right? Remind us of how you represent these on a graph. What are your considerations? All right, the next part now says, it's going to talk about the number of people now. It says, a car, remember how many cars were there? X cars, right? And then one car can carry 4 people. So it means that the number of people in cars is 4x, guys. 4x is the number of people in cars because there are X cars and each car can carry 4 persons. So if there are X cars and each carry 4 persons, then this represents the number of persons, number of people in cars. Then it says that a minivan can carry 6 persons. Remember the minivans now, there are Y minivans, and there are 6 persons per minivan. So the number of persons in the minivan is 6Y. So the sum of these two would represent the total number of persons that is carried in X cars and Y minivans. All right? But understand that? But understand that?
Yes, sir.
Then this says there are at least 60 persons to be taken on a tour. No, at least, no, oh, at most, sorry, at most. At most means 60 is the most. So it means it's less than or equal to 60. So the total number of people, which is actually this, can't pass 60. 60 is the most. All right? Must be less than or equal to 60. That's what at most means. So the total number of people on the tour, which is 4x plus 6y, this represents the total number of persons carried by the X cars and Y vans. Can't pass 60. It has to be less than or equal to 60. As it said, at most. So don't let the word most just cause it to write the less than sign or the greater than sign of me. At most 60 means they can't pass 60. 60 is the most. So the number of people must be 60 or less. And then someone show this inequality. Now we have established this from the information up here. But what this is just a reduction of this expression, they divided through by 2, because each of these can be divided through by 2. All right, so all we're going to do is divide this now by 2 and get what they told us to show. Divide this by 2, we get 2x. Divide this by 2, we get plus 3y. Let's say equal to divide this by 2, we get 30. So this is what we have shown right here. All right, so that is the answer shown. But I go to that. But okay?
Yes, sir.
Yes, sir.
All right, let's continue. Question now says, on the grid below, plot the 4 lines associated with the inequalities, and then shade and label the region which satisfies all 4 inequalities R. So we want us to draw the 4 inequalities on this graph. Draw the lines first and then shade the region. All right? So like we're representing these inequalities on a graph. Let's see what we show for each one, one. What I'm going to write now in red, you don't need to write it, but this is what you think about. This is what you consider when you're actually going to draw the lines and shade the region that you want or identify the region that you want. So this is the first one. Remember, inequality on a graph is about being above or below a line. You want the region that is above or below a line. The greater than sign on the inequality, on the linear inequality, generally means above, but it means above when the y on the left side of the inequality is positive. So because this y over here on the left side of this inequality, the first one, is positive, this greater than sign means that we want above a line. So first word I'm going to put down for this one is above. I want to go above a line. So the line that you're drawing now, it either can be broken or solid. A broken line is drawn when the line is not a part of the inequality. And the line is not a part of the inequality when the equal part of the inequality symbol is not there. So if, for example, this was just a greater than sign, it means that I will be drawing a broken line because the line now would not be a part of the inequality. But because the equal is actually there for this one, the equal is actually a part of inequality. This equal means that points on the line itself are also valid. And to show that points on a line on the graph representing the inequality. The line is also, points on the line are also valid. You draw the line solid, an unbroken solid line. So the line is going to be drawn solid. And then the line you draw now is the one associated with this inequality. The line associated with inequality is obtained by just replacing the inequality sign with an equal sign. So the line I'm talking about now is the line x plus y equals 8. This is the line associated with this inequality. All right, that is it. That is the line associated with that inequality. And then now, we're going to have to draw this line over here. We're going to have to draw it solid. And then after we draw, we're going to shade the region above it, above that line. So how do we draw this line? That's an easy line to draw, the x plus y line. If x plus y is equal to 8, it means that that line will cross the y-axis at 8 and also cross the x-axis at 8. It's one of those common lines. If it was x plus y equals 20, for example, x plus y equals 21, then it would cross the x-axis at 20, y-axis at 20 across x-axis at 20. Note, I said x plus y, not 2x plus y, or not x minus y, or not 3x plus y. X plus y equals a number. There will always be a line like this, crossing the x-axis and the y-axis at that number. So, in a general sense, if the line is x plus y equals n, then an x plus y equals n will cross the x-axis at x value of n and cross y-axis at a y value of n. The more things you know, the better. All right? So, this point, this line, therefore, cross the y-axis at 8, and 8 on the y-axis is 0, 8. And it crosses the x-axis at 8, and 8 on the x-axis is 8, 0. So this line is going to pass through these 2 points. Very good so far? But okay so far? Going step by step in
Yes,
Oh,
sir.
Oh, this is revisions. I'm going step by step. I've not done one like this in a while. Then this second one now. The y on the left side is positive. So this less than sign means below. When the y on the left hand side of inequality is positive, the less than sign means below. So going below this line, we want the region below this line. And again, the equal is a part of inequality. So we need the line to be a part of the inequality. Points on the line are also valid. And when that is the case, we draw a solid line, not a broken line. And the line associated with this inequality is just obtained by replacing the inequality sign with an equal sign. So the line we're talking about is the line y equals x, which again is another easy line to draw. Y equals x passes through all the points where the x and the y value, x and the y values are the same. So you pass through, for example, 0, 0, and for example, it will pass through 8, 8. I'm just randomly picking these two. Could I put any two? Could put 5, 5. Could put 3, 3. Any two values, but because I have these values of 8 that I'm going to have to indicate on my graph, these values of 8, then I'm just going to use the 8, 8. All right, so I'm going to use 0, 0, 8, 8. I might use other points still in, but the line y equals x pass through points when x and the y values is same. Always a diagonal line of like. All right, then the third one now is this one. X less than or equal to 9. This one don't have any y in it. It's just an x equal line, really. All right, and the x on the left side is positive, so the less than means below again. So going below a line. So the line is going to be a vertical line. All right, again, the equal part of equal is going to draw a solid line. And the line associated with this inequality, the line x equals 9. And x equals 9 is a vertical line passing through 9 on the x-axis. Pass through 9 on the x-axis. Vertical pass through 9 on the x-axis. And below a vertical line means that you want to the left of that line. That's what it means. All right, then we come to this one. Let's put the information down. This has 2x plus 3y. So it has both x and y in it. The y is on the left side of inequality, and see it is a positive y. So because the y is positive on the left side, the less than means below. Write it on the here below. Again, the equal is a part of the inequality, and so the line is a part of the equality. So points on that line are also going to be valid points. And so to show that that is the case, we draw a solid line. A solid line is drawn. And the line associated with this inequality now is the line 2x plus 3y equals 30. So we're going to have to draw this line on the graph. I want to draw this line quick and fast. I'm going to show you a quick, easy way to draw a line like this on a graph. You should know it already from the class, but we're revising, no problem. So let's let me zoom in and show you. So I want to draw 2 points on this line. I'm going to put on 2 points, guys, 2 points. We want to make one of them be a point on the x-axis and one of them be a point on the y-axis. So we're going to do one on the y-axis and one on the x-axis. So we're going to do the first point, to give it an x value of 0. And the second one, you're going to give it a y value of 0. So this one is going to be on your y-axis. This one is going to be on the y-axis. This one is going to be on the y-axis. And this one is going to be on the x-axis. X-axis. Right? Because the y value is 0. Now, how do I work out the value for here now? How do I work out the value that goes here? I take the 0 and I put it in the equation right here for the x. All right? And that is the x value of 0. So when you put the x here, so this whole thing is eliminated. And so you're now left with 3y equals 30. If 3y is equal to 30, then divide by the 3, y is equal to 10. So it means that the point is 0, 10. But understand that? But understand that?
Yes, sir.
Good.
Yes, sir.
Then this second point now, we're going to put a y value equals 0, because what a point on the x-axis to draw the line quickly. So we're going to put the 0 here for the y value. So you put 0 here for the y value, you're going to cross this out altogether. It's going to be gone. I'm going to be left with 2x equals 30. And if 2x is equal to 30, you divide by the 2, the x is equal to 15. So it means that when the y is equal to 0, the x is equal to 15. And so you put 15 right here. And so those are 2 points. That point 0, 10 and 15, 0 are 2 points on this line. And so we're going to draw it. And that's what you consider to draw your graph. Now, as I said, everything else that I've placed in red, you don't absolutely need to do it. Right? But I'm showing you what you consider. What the things you consider to draw your region, to draw the graph and shade the correct region and stuff. All right, let's do them one at a time. So x plus y equals 8, and we're going above that line. X plus y equals 8, and we're going above that line. It passes through 8 on the x and the y axis. So it's here. So 8 on the y axis here, and 8 on the x axis here. So I'm put on that point and that point. So also going to pass through 4, 4. As x plus y equals 8, it's going to pass through 6, 2. X plus y equals 8, it's going to pass through 2, 6. X plus y equals 8. So line we're drawing now, x plus y equals 8, pass through all those points. But all I said is that we really only needed those 2. All right, but I'm putting all these points because I'm drawing it free-handed, right? That's why I'm putting them all in. So let's use a ruler now and draw that straight line through these points. And when you draw the line, you make sure you label the line with the equal sign. X plus y equals 8. Because the line is the equal mark. Know that I've drawn the line solid. Then to show that I want a region above the line, I'm not going to shade it, but my region that I want is above that line. I'm going to put an arrow pointing upwards to remind me that I want above this line. So the region that I want is somewhere above this line right now. But I'm not going to shade anything yet. I'm going to wait and put in all the lines and the shade on the common region. So that's the first line. And I'll put this arrow to remind me that I want above this line. So I can't use anywhere under here. The next line is this one, y equals x. That one pass through points with x and y value the same. So see it here now. Passes through 0, 0, and it passes through 4, 4. Right? That's 4, 4. And it passes through 8, 8. Right here, so y equals x pass through those points. I'm also going to draw that line. Oh, y equals 8, y equals x, sorry. That's it. You have to draw it with a ruler, guys. Don't draw it from the line. You label the line with the equal sign. This line is y equals x. And what do we want? We want above that line or below that line? Let's see. We want below that line, right? So to show that I want below that line, I'm going to put an arrow pointing down like this. So it means that the region that I want so far is somewhere in here. Below one and above the next one, right? I don't want anywhere over here. I don't want anywhere near. And I don't want anywhere under here. I want these arrows are directing where I want. So right now, I want somewhere in here. But we're not finished yet. We have other lines to put in, all right? We're narrowing down the region that we want. So the third inequality now, sorry, is this one. And the line we want is x equals 9. X equals 9 is a vertical line passing through 9. If you don't remember, but our x equals 9 is a vertical or horizontal. Just remember the y-axis is x equals 0. So x equals 9 must be vertical like the y-axis, just as it passed through 9. It's 9 here. So we want a vertical line passing through 9 for x equals 9. So let me draw it here now in blue. So 9 here, I want a vertical line passing through 9. So this is it. That's our vertical line passing through 9. All right, this is it. I'm going to leave it at the top here. This line is x equals 9. I'm going to put the arrow to the left because we want below that line. Below a vertical line is to the left. So I want to the left of this line. So it means that the region that I want so far, remember, and it's below this. Let me put back this arrow in here. This one. Let me move back this one and put it here. Below this line. Move this. I also want above this line. So the region that I want somewhere is inside here, so far. Note that this piece exists right on this, right? That piece is there. It's a valid piece of line because it is above x equals 0. Above y equals 0, I mean, right? That's what this is, above. That's what it means that the values are positive. So the region that I want is somewhere inside here so far. But we're not finished yet. We still have one more line to put in. One more line to put in. All right? Let me take this off. So the next line, the last one, is this one. And we worked out that it passed through 0, 10 and 15, 0. So 0, 10 is up on the y-axis here. And 15, so 15 and so 15, 0 is all the way out here. So you would need to use a ruler now and draw the straight line through that. You get me? That is it. Use a ruler and draw the straight line. Look, let me see. Can shift it down instead. Can shift it down a little bit. It's not moving. I don't want to redraw it. Nah. Anyway, it passes through this point and it passes through that point. I can test those 2 points, right? And then for this line, label this line as well. So this line out here, this line, this one, this last one that we just drew a while ago is 2x plus 3y equals 30, and we want to go below that line. 2x plus 3y equals 30. This line is 2x plus 3y equals 30. They always label line with the equal sign, you know. And we want to go below that line, below this line. So we look at it now. The region that you want is inside here now. You understand? Because it is below this one, above this one, to the left of this one, and below this one. So the region that we want, and then someone put a T in there, and put the T in there in purple. I want us to shade it, shade it in green. So the region that I want is inside here. That region is the region that I want. When I go to that, that's the region that satisfies the inequalities. It means that you can use any number of combination, any combination of cars and vans inside this region or along these sides, because these are all solid sides on that shape, that polygon. You can operate anywhere in that region, including on the line. Any combination of vans and cars will satisfy your conditions. All right, and basically that is it so far. But good.
Sir, I'm so sorry. I just let my device died and I had to join on the next one and it took a while. Could you wait? Is
No,
there
you
going
got,
to be a video on this or?
yeah, man, this is being recorded.
All right, that's fine then. Never mind.
You have to ask for something specific. Yeah, with a whole explanation a while ago. So you have to go and watch the video. All right, you have to go and watch the video. Go and watch the video. As soon as we're done, watch the video. I'll show you the video right after. But that's, we have just drawn the graph, explain everything, or draw the graph or whatever. All right, so let's continue. All right, the next part now says, all right, let's see what it says next. So draw the graph. It's R, this is a shade region, not T, R. Where did I get T from? It said R, put the R in here. R. Mark R in the region and shade it. I don't know why they want R and shade it. You either ask for R, a letter alone, or ask it to shade. But I want R and a shade. So label it R and we also shade it. All right, that green area satisfies all the conditions. Put the R in there as well. Let's look at the next part. Next part now says, determine the two combinations, XY combination we are talking about. You know. Where X is the number of cars and Y is the number of minivans. The two combinations for the minimum number of cars and minivans that can be used to carry exactly 60 people. Exactly 60 people. Remember, we did work with 60 people. Remember that a car can carry 4 persons and a van can carry 6 persons. Right? The car can carry 4 and the van can carry 6. So this represents the total number of persons. To carry exactly 60 persons, you want this now to be equal to 60. All right? You want that to be equal to 60. Now, when we simplify this, this becomes 2x plus 3y equals 30. So I'm still on the line that we use for the inequality that spoke about the 60 persons, that the 60 persons was the max. We want to carry exactly 60 persons now. So we're working with the equal 60. If you're working with the equal 60, it means that you're on the line. You're on the line. So what it is that you want points on the line that will now work. And you see, it wants the minimum. So what you have to do now is look on the line and find 2 vertices of a common region on the line, because maximum and minimum of anything is always obtained at the vertices of your region. Maximum and minimum of anything you want to find with this linear programming is always obtained at the vertices of your common region, because the vertices are where you have your extreme values. So we need to look at this line, look at the vertices of a common region where this line pass and find the points there. That's how we're going to get the 2 combinations. All right, so it's talking about, use a different color. Let me see, might have to use red. It's talking about This line, no, this is a line that carries 60 persons, exactly 60 persons, exactly 60 persons. You have to be on this line, P-E-O-P-L-E. You have to be on that line to carry exactly 60 people, because this was the line that we resulted from the number of persons that can be carried. Because you're carrying exactly 60, see, this is the formula, equal. And where it comes from 4 plus 6y equals 60, you know. All right, so we're on that line. And so we'll go to the vertices on this line, which is now this point and this point. So these represent the points. We're going to get the combination that can carry 60 persons. This point is 9, 4. This one is 9, 4. 9, 4. So if you have 9 cars and 6 vans, you will carry 60 persons. One, you can test it. And this point is 6, 6. This point is 6, 6. Meaning 6 cars and 6 vans will also carry 60 persons. You can check it for what? Look, let's check it right here. 6, 6. Meaning x equals 6 and y equals 6. Y equals 6 at 6, 6. Right? Let's just prove here that it carried 60 persons there. Y equals 6. It means that the number of persons here would be 4 times 6, remember it's 4x, plus, what was it, 6 times y, 6 times 6. This should be 24 plus 36. 24 plus 36 is 60 persons. That equals 60. So you see, you can carry 60 persons with this combination. And if you try the other one here, 9, 4, right here, let's try it right here. 9, 4, just to prove it. At 9, 4, the x equals 9 and the y equals 4. So remember, you know, it's 4 persons per car. So that would be 4 times 9 plus 6 persons per van, right? And it's 4 vans. So it would be 6 times 4. Now this 4 times 9 is what? 32. And 6 times 4 is 24. What am I saying? No, this is 36, not 34, 36. 4 times 9 is 36. 36. And 6 times 4 is 24. This also add up to 60. So I confirm that these are the 2 combinations of vans and cars. Cars and vans that can carry exactly 60 persons on the tour. All right, so that is the 2 combinations. Right, so the answer is 6, 6 and 9, 4. That is 6 cars and 6 vans. I'm just writing vans instead of minivans. And this one is 9 cars and 4 vans. All right, so that's a 2 combination of cars and vans that can carry exactly 60 persons. 6 cars, 6 vans, or if you like, you could use 9 cars and 4 vans. But I go to that. But okay.
Yes,
Hello. All right.
thank you.
This one now says the company charges $75 for each car to rent a car. So there are X cars, you know. So basically you're paying 75X to rent the cars. Plus you paid $90 for each van, and they're Y vans. So you're paying $90 times Y. This is the total amount of money you're gonna pay to rent the X vans and the Y cars. That is it. Based on what they have said. All right. So this is now representing the total money you're gonna pay for X cars and Y minivans, because it's $75 per car, and there are X cars. It is $90 per van, and there are Y vans. So this represents the amount that you pay to represent X cars and Y vans. It says, show that the minimum rental cost for this store, and here it says this store. Which store? I remember this is part D, you know, part 1 of D, part 2 of D. So this is talking about the same tour that they introduced up here, the tour that they are carrying exactly 60 persons. So we're talking about when they actually use 6, 6, and 9, 4. So I have to know what's the minimum rental cost that they're gonna use. So what you're gonna have to do now is put these combinations in this formula to see which one use the less money, which one use the minimum money, and the minimum money is supposed to be 990. So all you have to do is put them in here, right? So first combination was 6, 6. So I'm gonna put 6, 6 in there. So when it's 6, 6, you pay $75 times 6 plus $90 times 6. I'm gonna work that out. And when it's 9, 4, to me this makes sense. You know? 9, 4. Got the cars, the van's expensive, right? You're gonna pay $75 times 9 times 9 cars plus $90 times 4 vans. I'm gonna see which of these combination costs you the less. So this is work this out and work this out and see which one is less. And then that minimum is supposed to be 990. Based on what they are saying. All right, if our calculation is right, small of these two calculations, these two payments supposed to be 990. All right, so let's look at it. So it's 75 times 6, that's right here, plus 90 times 6. See, 990 if you use this combination, 990. So you're paying $990 if you use 6 and 6, 6 cars and 6 vans. Then here now, use 9 cars and 4 vans. 9 cars and 4 vans. Let's see what that would be. So it will be 75 times 9. So I'm going to change this 6 right here so to 9. And then change this 6 right there to 4. 4, change that to 4. And that would be 1,035. So to carry the same 60 persons, what it's basically saying is that if you use this combination of vehicles, you're going to only pay $990. While if you use this combination of persons, you're not going to pay $1,035. So the cheaper option is to use 6 cars and 6 vans. And so that is the answer. So I can say, therefore shown that 990 is 990 is the minimum cost when 6 cars and 6 vans, I'm just going to add vans, are used. To carry 60 persons. And that is it. Question done. But okay?
Yes, sir.
Yes, sir.
And like this, you
Sir.
can work over again. It's not like this, you can work over again. All right. You need to go and work the question over again. Watch over the video and get the full understanding of it. All right. So to give you one like this again, you know how to approach it. All right. All right. That's it. Let's move to the next question. We have 2 more. 9 and 10. Let's put this one. So this one now is our circle theory. Circle theory. It says H, J, K, L, and M are points on the circumference of a circle with center O. MK is a diameter. So here we have a diameter. Remember, angle subtended by a diameter is 90 degrees, right? And it says, and it is parallel. So this line now, this line is diameter is parallel to this one. So remember, once you have parallel lines, you must be thinking about your U angles. Remember, the U angles add to 180 degrees. And the U angles, for example, if I join these two bottom line here, those two parallel lines. So these angles now will be in the base of the U. Those two angles are the U angles, co-interior angles. They are happening for them. They add to 180 degrees. Then also you must be thinking about your Z angles. So your Z angles gonna like you go to the top of one, connect the bottom of the other one. Alternate angles like this now, connect them top of one to the bottom of one like this. It means then that these now are your Z angles in there. This angle here equal. So remember you're also looking for Z angles, which are called alternate angles. And alternate angles are equal. Right? So once you have parallel lines in a question like this, in a diagram like this, you have to be looking for your Z and your U. All right? Looking for them. Note you also have U angles up here. So it means then that this angle across here and this angle across here, they add to 180. All right? So you're looking for them. So that is basically it in terms of Z and U. All right, so that's what they've said so far. That's what else did they say? Also said that these two lines are equal, and you can see that with these marks. It means that this is an isosceles triangle. So those two lines are equal. Let me say all of this angle and all of this angle is the same. And there are the angles that are opposite the equal sides. So those two angles are equal. That becomes an isosceles triangle. So once you see equal lines, you're thinking about isosceles triangles, guys. You're thinking about isosceles triangles. That should be a chain of thought. It's parallel lines. Start thinking about you're looking for U angles and you're looking for Z angles. You see two lines equal, you're looking for isosceles triangle and so on. All right. Then it says no, it says no, this angle is 38. Where is it? This angle right here is 38. All right. Then we want us to explain the reason why this angle is 38. Now, which angle is that? HJM. Where's H? HJM. Where's M? HJM. This angle. So I was basically saying, why is this angle 38? We just said it a while ago. It's an alternate angle with this one. So these two angles are equal, alternate angles. So this angle is HJM. It is 38 degrees of Z angles. So now right, alternate angles are equal. They are equal because alternate, which we call Z angles, are equal. And put it on the diagram as you find it. Put it on the diagram. Get into the habit. The final angle, you put it on the diagram because it will help you. All right, that angle is 38 degrees. All right, so we have that one. What else I want? It's an angle MJK is 90 degrees. Why is it 90 degrees? MJK, let's look at it. So it's M to J to K. That's this angle right here. Now that angle is subtended by this diameter. This diameter is subtended that angle. That's why this angle up here says 90 degrees. Angle subtended by a diameter is 90 degrees. So that is the reason. So right, subtended by a diameter. 90 degrees because angle subtended by a diameter is 90 degrees. And this angle is subtended by a diameter. That's why it's 90 degrees. Body good so far?
Yes, sir.
All right, let's put it on the 90 degrees right here. Let's mark it. So put a line here and there. Show that 90 degrees. Subtended by this diameter. It's 90 degrees. All right. So far, so good. Sorry. Let's continue. Next part says, determine the value of each of the following angles. Show detailed working where appropriate. So this one is not asking us for reasons. It just wants us to find the angles. It's not asking us for reasons. So just show working where appropriate. Yeah? So you can just basically calculate the angles and then show working. But if you want to write a reason, so I guess you're good to go. All right. MLG. MLG. Let's look at the diagram. MLG. So M to L to G. All right. That is this angle we want right here. So now this angle. All right. Let's look at it. All right. Let's look at it. This angle we want to know MLG. All right. So that angle is subtended by this chord. In fact, that angle is one of the angles in this isosceles triangle. So that angle and this angle is the same. These two angles are equal. Let's do it now. Because that's an isosceles triangle. All right, so that's an isosceles triangle. So these two angles equal. This angle says 90. We know this is. Oh, so these two angles are opposite angles in the cyclic quadrilateral. So if you can get that, we're good to go. But then also, this angle down here equal to it as well, because they are both subtended by this chord. So let's have some of these. All right, so this angle that I want is subtended by this chord. This chord is also subtended. This angle over here. So these two angles are the same, they are equal. Angles in the same segment subtended by the same chord. All right, same segment rule. But what happened now? Question is, how can we find this angle? Well, that angle is one of the angles in this triangle, which is a right angle triangle. This angle is already 90. This angle up here is 38. So this angle down here becomes 90 minus 38 because these two angles are complementary. They must add up to 90. So this angle over here is 90 degrees minus 38 degrees because it is complementary. That if you want to use total angle in this triangle is 180, same thing, but this is 90, you know. So them two must add up to 90. All right, so that equals 38. 90 minus 38, that's how we need to work out. And the 90 minus 38 is how much? So 90 minus 30 is 60, 60 minus 8 is 52. Correct? 52 degrees. What good with that?
Yes, sir.
All right.
Yes, sir.
So this angle is 52 degrees. All right, it's better. All right, it's better. 90 degrees minus 38 degrees. This angle right here. So this one is also 52 degrees. So I'm going to put on two of them on it. So this angle is also 52. And that's because of the same segment rule. All right, put on in red. So this angle is 52 degrees. 52 degrees. And this one in here is also 52 degrees. This one in here is also 52 degrees. And that's what we calculated right here. All right, so look at all these lines. All right, same segment. Angles in the same segment are equal. All right. So to do this now, we tell them say it equal the angle here first, and this angle, and this angle is what? MKG. MKG. So set it up like this. So this angle that I want is equal to angle MKG, which is equal to 90 degrees minus 38 degrees. which is 52 degrees. And why is this angle equal to this? Because angles in the same segment are equal. Angles in the same segment are equal. That's serious. All right. The next angle I want is angle LGK. We don't use the U angles yet, right? Angle LGK. I want to use the isosceles triangle. LGK. Let's look at it now. LGK. Where's that angle now? L. Where's L? L to G to K. We're talking about. We're talking about this angle right in here. So that angle. All right, let's look at this now. Now that angle is subtended by this arc. See, if you come back, it's subtended by this arc. That arc is subtending this shape. This arc is also subtending this angle up here. This angle up here. So right now, these two angles are the same. So if I can find this one, then I have that one. All right. So how can I find this one? Let's see. How can I find this angle right here? All right. Now remember that this angle, this triangle is isosceles. What do we have? Where is it? This triangle is isosceles, right? Look. This is an isosceles triangle right here. So it means that all of this angle, which is 52, is equal to all of this angle, must be 52. And then now, part of this 52 degrees is 38. So the piece of that 52 degrees right here that we don't know is 52 minus 38. But can I get that? But I good at that?
Yes, sir.
All right. And that is 14. So this is 14 degrees. And that's why this angle over here is also 14 degrees. Same segment rule again. Because this angle is 14. Let me take this out. So we use the isosceles triangle first. That is 14. And I'm going to just leave the calculations on the paper right here, right? But that whole angle is 52. But that's isosceles triangle. And then this angle here so becomes 14 and is subtended by this arc. The same arc is subtending this angle up here. So it means that this angle is also 14. All right, so I'm just gonna leave it like that. So this angle is 14 degrees as well, this one. Same segment rule. So the 52 up here is because of the isosceles triangle that it is with this. Subtract the 38, and then this one is 14 because of subtended by the same arc. All right. So it's 14 degrees. How we're gonna put it? We're gonna say, all right, this angle that I want is equal to angle LMK first. Equal to angle MLK. So this angle that I want is equal to angle LMK, which becomes 52 degrees minus 38 degrees, which is 14 degrees. Right? So this one is because same segment. So I'm just slow calculation. This one is same segment. That's why they're equal. And it's 52 degrees because of the isosceles triangle. Isosceles triangle. That's that. Anything else I want? Angle GHM. Let's look at it. GHM. All right, so we have all those angles. Another one, angle JHM. JHM. That one kind of easy because that's a cyclic quadrilateral we have here. And these two angles opposite each other, they add up to 180 degrees. The JHM is this angle one. It is 180 minus this one. All right, because the opposite angles in a cyclic quadrilateral are supplementary. So it's 180 degrees minus 52 degrees. That's what that angle is. But good at that?
Yes, sir.
All right, so that is 128 degrees. All right, so I'm going to write it down here. This angle that I want is equal to 180 degrees minus the 52 degrees, which is 128 degrees. That's because opposite angles in a cyclic quad are supplementary. That is the reason. But good at that? But okay? Everybody good with that?
Yes, sir.
Yes, sir.
Yeah. Awesome. Awesome. Let's see this point on this here. All right. Anything else? All right. Come to part B, which is our it's a bearings question, as you can see. All right, that's a bearings question. All right, this one says from a port L, ship R, see L here, so I have R right here, so all right. So from a port L, ship R is 250 kilometers hit here on a bearing of 065 degrees. So this direction is on a bearing of 065 degrees from here. All right, let's just put an angle on the diagram right now. But remember, bearing is the clockwise angle from the north line at the front position, right? So from here up to here, the bearing is 065 degrees. So it's like you're on the front position, face north first, angle to which you have a turn to the right to face up to R. That is where the 65 degrees is. Let me just draw that in. Let me just extend this line up, this north line. And it is this angle that is 065 degrees. 065 degrees with that angle, and the distance is 250. All right, it says ship T is 180 kilometers from L as well. So from L to ship T, distance is 180 kilometers shown in the diagram, but that bearing is 145. So again, at this front position, it means a different color for this one. Standing at the front position, facing north first, you have to turn to the right 148 degrees in order to face down to T. So that blue angle becomes your 148 degrees, all of it. It means that we can deduce the angle in between here, in purple. The angle between here, between these two sides, is now 148 minus 65. Because the total angle is 148 and up to here is 65. So the angle inside here is 148 degrees minus 065, same as 65 degrees. All right. and you work out the angle in between those two sides, and then we're going to be able to use cosine rule. That works out to be what? 148 minus 65 is how much? How much is that? Nobody did that, can tell me? Nobody did it and can tell me? All right, beat myself. 83 degrees. And I put the question, guys. I can't just get them on the work, man.
Sorry, sir.
All right, at 83 degrees between those two sides. And then once you have that, now you can find this side over here is the cosine rule, because you now have two sides and angle between. So we're good to go now, you know. Good to go. Question says, complete the diagram by inserting the values on angle RLT. You see there? The 83 degrees they want. And we have done it here. See there? That's what they want. We have done it before we asked, before we read the question. Then calculate the distance RT between the two sheets. That's that one. Cosine rule we're going to use for it, right? Sorry. So cosine rule. Cosine rule. Cosine rule for RT. So it's going to be that. Start like Pythagoras' theorem. RT squared equals this side squared plus that side squared. Remember, it starts like Pythagoras' theorem, guys. Cosine rule starts like Pythagoras' theorem. 180 squared plus 250 squared. But you have to subtract a piece. Subtract 2 times the product of these two sides, the 180 and the 250. They take the cosine of the angle between them, which is the cosine of the 83. And what we can do, instead of trying to do it in two lines, we can move this square and the square root this side and drop off this square. Like that. You have to be able to do the mathematics that 3 in 1 line, guys. Come on. All right, so I'm gonna just put that in the calculator now. Let me go on the calculator and show it. I'm struggling. Can't help me, guys. I can't help me. I'm struggling here. It is cold. It won't leave me alone. 250 squared minus 2 times 180 times 250 times the cosine of 83. That comes out to be 289.7. Let's just call it 290. 3 significant figures. I'm going to write 290 kilometers. I'll put on the diagram. So I'm going to write equals 290 kilometers for this one. All right. Very good so far? Very
Yes,
good.
sir. Yes, sir.
Next thing I want is the bearing of T from R. When you're going to do bearing like this, you want to show it on the diagram and figure out how you're going to use it. So always note the from position. So I want the bearing from R to T. So the bearing must be measured at the from position R. I want to show that bearing diagram on the show that bearing angle on the diagram and then figure out how we're gonna get it. More than likely the angle in the triangle, the from position will be a part of the calculation. Most times that is the case. Let's see. From R to T, we want the bearing. Let's show that bearing angle on the diagram from R to T. So R up here, so want the bearing down to T from R. All right. So we're gonna show it on the diagram and then figure out now how we're gonna get it. So I have to draw the north line at R. Like this. And then this is the line down to T. Let me extend this right up through this diagram. This is the north line. Let me just extend it right up through the right. That's the north line. And the bearing angle that I want is this one. Turn to the right until you face T. That's the angle that I want. Now I'm saying to you, 90% of the time, when you want the bearing from this point here, the angle inside the triangle will play a part in the calculation. Let's look at it. So I'm going to call this angle alpha. And then look to see how this alpha could play a part in the calculation because it can be found. I think I can see it already. You know. We want this red angle out here. We know the angle inside here so is 65. So this angle over this side can be found easily because remember that those will be no co-interior angles. And then after find this angle here, and also find the alpha, we can say total angle around the point is 360 degrees. And that's a premise on which we can find this angle here that we want. Let me see if there's another way. There's always another way, but let me just see if I can see another way right now to show you. Let me look. Sometimes you want to find this big angle right here and you can't see what it is right away. Then you can decide to break it like this with a vertical line. So when I break it with a vertical line, up to here will be 180. But then I would need the angle piece inside here. And my Z angle would be with this line. So I would have to find this angle in here. So, you know, it's a lot of work that. So I'm not going to use that approach. Right? I think the best approach right now, this is what I'm seeing, is to find this angle over here and write it in blue. I'll write it in red. This angle right here is co-interior with the 65. So it is equal to 180 degrees minus 65. This one, 180 degrees minus 65 degrees. How much is that? How much is 180 minus 65?
115.
Oh, not takes so long.
115, sir.
Plus 115 degrees. So this angle is 115 degrees. So you see, if you can find the alpha, which we can using cosine rule, why we can use cosine rule? Because we have this pair of the 83 degrees and the side opposite to it that we know. And we can use that pair with this pair, cosine rule, to find the alpha. And then now we're gonna say total angle, we know the alpha, we're gonna say total angle around the point R is 360. And so that's what we're gonna know what this is. Let's call this angle here, so theta. Let's write an expression for it. So this angle that we want, I'm gonna write it in red. This angle here that we want, we're gonna call it theta. It's gonna be equal to 360 degrees minus the 115 and also minus the alpha. And we're gonna have to use sine rule to find the alpha inside here. All right, we can do the calculation right here, saying on the screen. Let me do the sine rule and find the alpha down here. So first, we need to find the alpha from here. So I'm going to use sine rule for alpha right here. So let's write it. Sine rule for alpha in blue. Sine rule for alpha. So I'm going to say sine of alpha. Always start with what you want. Sine of the angle that you want. With the side opposite to it, which is 180, equals sine of the angle that we know, which is the 83. Over the side opposite the 83 is this side that we just saw on the 290. So we need to find the alpha. So we can find the alpha. You can take the 180 and multiply it up here. Remember, always put the values in front of the trig. Always put the values in front of the trig when you multiply that trig by a value. And then to get the alpha, we're going to take the inverse sign. So see it, you know, the alpha is going to be sine to the minus 1. I'm going to step by step and show that. Firstly, the sine alpha is going to be this with the 180 multiply upon it. 180 and the sine of 83 degrees divided by 290. So if sine alpha equals that, then I can inverse the sign on this side. So take off this sign and put sine to the minus 1 of the entire value. And work out the alpha right here, the calculator. Let's put up the top on this just to show you how the calculation is done. All right, so come back to this. It's gonna be sine to the minus 1 of a fraction 180 times the sine of 83. Make sure you calculate in degrees. You can see it up here, the DEG. The calculator, yes, it's in degrees. And then dividing that by 290. I'm getting 38. 38 degrees, 38.0. I'm going to try 38 degrees. I'm getting 38 degrees. So the alpha is 38 degrees. Nice and easy. So now that I know that alpha is 38 degrees, I'm going to take it down and put it in the formula up there. So that expression up there and get my bearing angle. All right, the bearing that I want. So that bearing angle becomes 360 minus 115 degrees minus 38 degrees. We'll get the bearing angle that way. So it becomes 360 minus 115 minus 38. 207 degrees is that bearing angle. But good? But okay with that?
Yes, sir.
Yes, sir.
All right, so I did it up here. So just have to basically copy it down in the space down here, so, right? So I have to copy down the sine rule for alpha and then the bearing angle. So I'm just gonna leave it like that. It's on the page. So we have a C diagram right here. So C work on diagram. And this angle is theta, which is 207 degrees. That's the answer. See the work on the diagram. And that finishes this one. End of that question. All right, one question left, one question to go. And then we're gonna call it a night. All right. All right. So this question gives us these two matrices. They must know that that's the anticlockwise 90-degree rotation matrix with a negative up here. Anticlockwise 90-degree rotation about the origin. Which they are telling you that it is there is a rotation of 90 degrees anticlockwise about the origin. That's this matrix A. And then you must know that this matrix is a y equal minus x reflection matrix by observation. But on sight, you must know, see, it represents a reflection in a straight line, y equals minus x, y equal minus x reflection matrix. This one, you need to know it like that. Not every question I'm going to give them to you. All right, it says write the coordinates of P prime, the image of P after it undergoes a rotation 90 degrees about the origin. So in other words, we're going to apply this matrix to this point. All right, we're doing the rotation. Simple, we're going to multiply the matrix by the point. So that becomes apply the minus 1, 0, minus 1, 1, 0. I apply that to the point P7, 11. And then work it out. So it is 0 times 7 is 0, negative 1 times 11 is negative 11. And then 1 times 7 is 7, 0 times 11 is 0. So this is 7. Therefore, P prime will have these values in its coordinates, negative 11, 7. Just use a column vector to do the calculation. The question asks us for the coordinates, which must be written like this, like this. All right, that is it. So this is the answer right here. But okay with that?
Yes, sir.
All right. Next part now says T is a combined transformation A followed by B. Remember, A followed by B is B times A. Right? And that is T. So that means that T is the second one multiplied by the first one. A followed by B is B times A. It says determine the elements that represent transformation T. So we're going to calculate B times A to find T. That's what we're going to do. So T equals B times A. What is the B? B is the second one right here. 0 minus 1 minus 1, 0 times A is the first one. 0 minus 1, 1, 0. No, Answer value this is going to be a reflection line. Let's see why that is so. So it's like we have a 90-degree rotation, right? And remember, when the rotation is two reflections go with one rotation. So if you have a rotation of 90 degrees, then the two mirror lines that you're using are 45 degrees apart, but the rotation angle is always twice angle between the two lines in that combination. If one of the lines is y equal minus x, the lines that are 45 degrees, the y equals minus x, are the y-axis and the x-axis. So the answer for this question is going to be either this line or this line. So it's either going to be minus 1, 0, 0, 1, or it's going to be the x-axis, which is 1, 0, 0, minus 1. So you know what your answer is supposed to be already, one of those two. I'm not going to get into precisely which one it is, but I know it's one of those two. Because two reflections go with one rotation. So the combination must be a reflection. So to multiply these two matrices now, guys. Let's look back at how we do it again. I multiply the rows of the first matrix by the column of the second matrix, the columns of the second matrix. And the answer is going to have these four values. So the first value here is positioned in the first row and the first column. So to get it, you multiply this first row by this first column. All right, I multiply them first element in the row by the first element in the column, second element in the row by the second element in the column. So we see first element times first element, second element times second element, first element times first element, second element times second element, 0 times 0, and minus 1 times 1. The 0 times 0 is 0, and minus 1 times 1 is minus 1. So we're done already, you know, so this is a 1 done as a no, and this is 0, and this is 0. You know? Because I already know that it was one of those two. That's a y-axis reflection. But if you want to finish it, no problem. But the more things you know, the better, guys. The more things you know, the better. So to get this value now, it is the first row and the second column you multiply. So you multiply this first row by the second column, or you multiply them. First element in the row by the first element in the column, second element in the row by the second element in the column. You can say that it is 0. 0 times minus 1, and minus 1 times 0. So that works out to be 0, which you know it's supposed to be. So this value is 0. Then the zeros are always across each other on the diagonal, right? So this is also going to be 0, but let's work it out still, this value. So it's second row, first column. So to get it to multiply this second row by this first column. So then it's first element times first element, which is going to be 0, because negative 1 times 0 is 0. And second element times second element, and 0 times 1 is also 0. So it confirms that this value is 0. Then this last value that you want now is positioned in the second row and the second column. So to get it, to multiply this second row by this second column. Same thing again. First element times first element, second element times second element. Now this first element times first element is a positive 1, because negative 1 times negative 1 is positive 1. All right. And so, and then so negative 1 times negative 1 is positive 1, and 0 times 0 is 0. So this works out to the what I will know which one. That's a y-axis reflection matrix. This is the answer for T now. Then I ask us to describe geometric transformation T, geometrical transformation T. A reflection in the y-axis, that's what it is. A reflection in the y-axis. In the y-axis. That's it. Transformation T is a reflection in the y-axis. But good? But okay?
Yes, sir.
All right. Moving right along. This question now says 2 by 2 matrix C is defined as this. It says determine the value of K if it is singular. If a singular matrix has no inverse. Has no inverse. Because the determinant is equal to 0. So the determinant of C is equal to 0. And the determinant equals 0 now, guys. This product, first diagonal product, equals the second diagonal product. And that is the case now. And the determinant equals 0. They call it the A times D. A times D becomes equal to B times C becomes equal to B times C. So the 3 times 4 becomes equal to 6 times K. 6 times K. So this is 12 equals 6K, which implies that the K equals 2. That is the answer. But okay with that? But good at that?
Yes, sir.
Yes, sir.
Huh? Yes, I said. What I said, yes?
Yes,
Yes, sir.
Beautiful. Alrighty, let's move on. Oh, vectors, and we're done after this. It says in the diagram below, O is the origin and OX is the vector U right here. No, OX is the vector U right here. Then OY is the vector V. So OY is the vector V right there. It says OX and OY are extended such that X and Y are midpoints of OA and OB respectively. So this becomes the midpoint of this side. And this becomes the midpoint of this side. So what it means then is that these two lines are equal and parallel. So these two vectors are equal. So it means that vector from here to here is also U. And similarly, this side is equal to this side. Two pieces equal. On the same straight line, same direction. So the vector from here to here is V just like this. That means that OB is 2V and OA is 2U. Let me tell us right that up here. On the information. So we're gonna write up here that OA is U and OB is OB. This and that information. And I want us to calculate vector BX. So calculate BX. Since we know all the portion vectors, right? We can use the portion vectors to work this out. So BX becomes equal to O times the last, which X is the last, minus O times the first, where B is the first, OB. Because we have the portion vectors, we can use this portion vectors formula to do it for displacement vector. O times the last minus O times the first, so it's OX minus OB. The OX is this U right here, minus the OB is this OB right here, OB, and let's see. The diagram would also show you, right? To go from B to X, you have to come back 2V, that's a minus 2V, and then go a U this way. I'll put another way. You could say, okay, do the U first, and a U will be any line parallel to this, or this side. So like you do this U first, and then that's a U, and then you're doing minus 2V. So minus 2V is a full vector like that, but in the opposite direction. So that will be minus 2V. It's still correct. It takes it from B to X. Excuse me, guys. Excuse me. All right. So that proves it. It is still correct. Anyway, you want to look at it. All right. What else I want us to do? It says, given that YA and BX intersect at M, and BM is 2MX, express BM in terms of U and D. All right. So BM is 2MX. All right. So what I'm saying, let's cut it and draw it on there so you can see. YA and BX intersect at M. YA and BX. All right. So YA is this one. And BX is this one. Let's draw that better. They intersect at M. And after they intersect at M, what they're basically saying is that BM has 2MX in it. All right, so BM has 2MX in it. See it here now. So this is BM. It is 2MX. And this is MX. 1MX. So it means that if I take off the MX back, take back off the MX, then the total line divided into 3 parts, where this is 2 parts and 1 part. So this then becomes 2/3 of the whole line. And this is 1/3 of the whole line. Might need that ratio. 2 to 1 line is divided by M. Let's see what they want us to do now. So remember, you know, we already have BX, you know, guys, this whole vector, you know. It means that PM is just 2/3 of this, you know. That's what it means, you know, right? And also, MX is 1/3 of this, because this is the entire BX up to here. All right, so take note of that. All right, so that information is very helpful. What I did on the diagram there, break it down and see the parts, see the fraction, right? What I want now is BM. Let's look at the diagram. So based on the diagram, BM, what did we say is now? BM is 2/3 of BX based on that information. Keep it simple. BM becomes 2/3 of the BX that we have. What was BX again? It was U minus 2V. Right, see there? BX, U minus 2V. And we are now saying that BM is just 2/3 of that. It's on that diagram. So let's put it 2/3 of this calculation. See there? 2/3 of U minus 2V. So it becomes 2/3 U. And then this time, this give me 4/3 minus 4/3 V. I multiply the 2 by the 2, get 4. That is it. But good at that? Yes, I need.
Yes, sir.
Yes, sir.
Very important to show this information on the diagram. Draw the lines and show the information on the diagram. All right. Next part now is that using a vectors method, show that ym to ya is 1 to 3. So show our working. To do this, we need to calculate the two vectors, ym and ya, and then extract the vector component out of them and get the 1 to 3. All right, it's a relationship between ym and ya first. So let's look at the diagram again. Ym and ya. Ym. So ym and ya. So we're gonna see how we're gonna find ym and how we're gonna find ya. Ya kind of easy, you know. Because remember, we have the portion vector of the y, and we have the portion vector of the a. It's ym now, we can work out how we're gonna get to ym. So let's look at it. How can we go from y to m? Just calculate this vector now, bm, just calculate it now. So see it right here, so now I'm gonna work out two vectors up here and then copy them down. So the ym first, y to a, sorry, ya first. Easy, because we just come here so and then go up here so. Right? So we come here so it's minus v plus 2u. Right? So the ya is come back that way minus v and then got 2u up there so to reach a. Diagram is showing us that. So minus v plus 2u. Or you can write it as 2u minus v. 2u minus v. That is the ya. Then we need a ym. How do we go from y to m? Can come out here so first with the v and then go here so with the bm that we just found a while ago. Remember what the bm is that we got. The bm that we got was equal to, let's go back at it over here. That was the bm that we got. The bm a while ago was this. I'm struggling, guys. You can't help me. Nobody can help me. Let's try to stop here the bm that we just found. I'm going to put the calculation on the diagram so you can see what is happening. The reference in the diagram. So this is our BM that we just found, right? This thing right here. Let's change it to purple. All right, so that's the BM. And I'm saying now to go from Y to M to get the YM that they want. We're gonna come out to B first and then go up to M. Right? So we're gonna say YM is the same as YB plus the BM. Now the YB is just this B plus the BM is this. The BM is 2/3 U minus 4/3V. Let's zoom in and simplify this. So this, I'm gonna put these two V's together now. So this 2/3 U, I'm gonna put that first. It's all the U terms. I'm gonna put that first. 2/3 U. Then this and this now. Look at it. This V is the same as, but it's our denominator of 3. I put this V as 3/3V. And this 3 minus this was -1. So it becomes -1 -1/3V. So this now is my Y. This now is my YM. All right, so I'm gonna copy these down now onto the next page and do the work. All right, copy these down to the next page, do the work, get the relationship between them, right? So please send me down here. And go again. So this is it. So let me move this one to the left over here. Put this one up here. And this is YM. So now I need to establish a relationship between these two vectors. Now, based on the diagram they are calling here, and you can see it now. Okay? YM and YA. Points on a straight line. So you're supposed to get that one is a multiple of the next. Right? By the other straight line. They're actually calling your points. So they are parallel vectors, they are common points. So it means to make a relationship between these two in order to generate this ratio that I want. So how do we do to show that these two vectors now are parallel? We want to get rid of the fractions out of this one. So to get rid of the fractions out of this one, clearly I'm going to multiply by 3. But remember, I always say get rid of the fractions first, because the fractions make it more difficult to see the relationship between the vectors. So to get rid of the fractions out of this one, we're going to multiply it by 3, right? Which is that 3, we're going to multiply by to get rid of the fractions. I multiply it by 3, I multiply this by 3 as well. So I'm going to get 3YM equal, multiply this by 3, you get 2U. Multiply this by 3, you get minus V. So we say that two vectors equal the same thing now. 2U minus V, 2U minus V. It means that these two things equal. The two of them equal the same thing. Because them equal the same thing now, we can jump to the step of equating. So we can equate the two vectors. All right? Can equate the two vectors and put this equals that. Or put this equals that. Doesn't matter. I'm going to put 3YM equals YA. Right? 3YM equals YA. Sorry about that, guys. Then now, in order to get this ratio, we need to get the vector component out of them. Right? So like I take the modulus of both sides. Right? So we want to get this ratio. And notice these two are one and the vector, right? So we get the show that you take the vector component, the vector component of them by taking the modulus of both sides. The modulus side 3ym equals YA. When you take the modulus, you can basically drop off the arrows because you don't want the vector components. So you end up with 3ym equals YA. And then once you do that now, you generate the ratio. Because this ratio really is a fraction. It is ym divided by YA equals 1/3. You know? So I want to get ym divided by YA. It's going to divide by this YA and then divide by this 3. So I'm going to end up getting ym over YA equals 1/3. Divide the YA under here and then divide this 3 under this side, under the right side. And this means that we have a ratio. This implies now that ym YA is 1 to 3. And that is what we have shown. Question like this, guys, you're going to do it again. Nice question. Nice question. This question you learn stuff from. You have to go and write these questions over again and go through the steps. Watch over the video. Do it yourself. You really learn from questions like this. All right? I like this question a lot. It's one of those special questions. All right? But good? Finish, you know, finish. Didn't know the session would take so long, but so it is. I'm trying to do it properly.
Yes,
But
sir.
all right?
Yes, sir.
All right, good. So I'm not going to bother doing the multiple choice. I'm just going to end it. I send the multiple choice answers in the group, but I encourage you to redo the questions. Right? Redo the question. Anything you get wrong, redo it. All right, and the special questions, you do them over, work them over again by yourself. You don't know what's coming on your exam now. You don't know what's coming on your exam, so you put in the work. You want to know that if a question like this comes on the exam, you can do it. This was just in 2022, you know, guys. It's just a couple years ago, and a recent exam paper this semester. So this is showing the level of questions that can come. There's nothing difficult about it. You just need to practice and focus on the method and approach that we use to do a question like this. So I suggest that you work over these questions, work them over, do them over again. I'm going to share the video in the group, you work them over again. We're going to get them as mock exam soon, you know, all these papers that we're doing. We're going to get them to do an exam condition, you know, and expect good marks when you get them to do. All right, that is it for today. So see you all. Next class we have online. I'm not sure if we're gonna have an online class on Saturday, but I'll send a message in the group. All right, I'm not sure as yet, but I'll keep sending work for you to do. We're in revision mode now and exam preparation mode now. And I'll let you know about the classes as we go. Remember, I'm away, right? Dealing with an issue. And we'll revert to our normal thing when I'm back. But I want us to keep working. I don't want us to drop the ball at all. We have to keep working. All right. So that is it for today, guys. I'm gonna send another paper to the group for you to continue working on. All right, everybody. See you all. Bye, everybody. See you.
Bye, sir. Bye, sir.
Cool. Bye-bye. All right. Sorry about the coffee, guys. It's killing me. All right. I'll see you all soon. Bye. I'm going to end it now.